Good morning, everyone. Welcome to our first introductory webinar on learning to make biofertilizers and biopesticides. For those who don't know us, I just want to tell you a little bit about BioWatch and Sky, the hosts for this seminar. BioWatch is an NGO that works in South Africa. We're based in KwaZulu-Natal with offices in Durban and Matuba-Tuba. We worked to challenge the industrial food system and to advocate agroecology as the most sustainable and appropriate way for food sovereignty to go forward, and to resist corporate control of our food system and natural resources, and secure farmers' rights and social justice and environmental justice. We work with smallholder farmers with support and training in agroecology to help them strengthen their practice and also their farmers' rights and access to resources. Sky is a partnership that BioWatch is one of the founding partners of, and it is active in Malawi, Zambia, Zimbabwe, and South Africa. And we currently have 16 partners in those countries that, and the partners are seeking to revive and enhance farmer-led seed systems and knowledge systems and deepen our understanding about their functioning within the context of supportive agricultural, cultural, and ecological practices. We work for food security and food sovereignty in the region, also with smallholder farmers, to helping farmers to become more seed, food, and nutritionally secure through agroecology, farmer-led seed systems, and improved crop diversity, and the revival of local knowledge systems. So we're hosting this webinar today as the last country that is doing this training with Juanfran. Juanfran has already trained partners in Malawi, Zambia, and Zimbabwe within the Sky, the Seed and Knowledge Initiative network. And we were going to have a in-person training earlier. We had planned that earlier in the year, but then with the onset of the COVID pandemic, we've reshaped and restructured that to be able to have our online learning with Juanfran and not miss out on that training. And for this reason, we've opened it up beyond the partners within Sky to include others in the Southern African region who might be interested in particularly enriching their soils through bio inputs, but also deepening their practice in that way. So to introduce Juanfran, he is a passionate person working to regenerate our agriculture. He's particularly interested in using locally available resources to create low-cost and sustainable solutions for farmers. He doesn't only work with smallholder farmers as we do, but he works with a variety of people from university level to people on the ground. And he's had extensive experience through on-the-ground experiential learning with culture people. He's worked particularly on these bio inputs with Jairo Restrepo, who's an agricultural engineer from the Brazilian Federal University of Pelotas. And he's deepened his practice on farms and through a variety of travels throughout the world, teaching on bio inputs and permaculture and agroecology. So we really would like to welcome Juanfran, and I think he'll explain as he goes more about himself. Yeah, and we're really in for a treat with this training. So welcome everyone. I hope you can all hear us clearly. Just to say that as we go, Juanfran's, in terms of the program for today, Juanfran is going to be doing an overview presentation to start with that explains what bio inputs are, why we need them, why it's crucial that we start looking at agriculture in a different way. And then we're going to have a short comfort break. After the comfort break, he's going to explain particularly about the course that he will be hosting with us going forward, how it's going to be structured and how it's going to work. And then we will have a question and answer session. So if any questions do come up for you during the presentation, type them in the chat box on the YouTube, and we'll be able to pick up those questions and put them to Juanfran at the end of the presentations. Thank you, everyone, and welcome, Juanfran, and over to you.
Thanks, Vanessa. Good morning, all, and welcome I'm going to share this. Welcome to the first session of a series of webinars that will happen during the next month and a half. So thank you so much for joining us. And I have to thank as well to Ski and BioWatch to give the chance to share this proposal. My name is Juanfran Lopez. Vanessa did a very good presentation of myself. Some of you already know me and others know, but what I do, I'm a teacher, a consultant, and a researcher about the production and application of bio input. And not just that, also about crop fertility, system health, etc. You can see more of my work in my web, juanfranlopez.com. To present this webinar, I would like to mention that it is focused in the African context. Last 3 years, I've been traveling in different countries in Africa. So this webinar is approach and that experience that I've seen so far with this travel. I'm going to speak a bit slowly with a small break in between sentences in order to give chance to the translation, because I know that some people will need translation to the local language. Firstly, always when I'm going to talk about a subject, I like to share the official definition so that people can touch base and know what we're talking about. Agriculture is the science of practice of farming, cultivation of the soil for the growing crops, and the rearing of animals to provide food, wool, and other products. To me, I like to give the approach of agriculture as the culture of humans on the earth. But how is the current state of agriculture? This is how looks a common agricultural landscape under conventional management. We can see a bare soil, tillage, no structure in the soil, no organic matter. So to me, the question is, how is the current state of agriculture? It's a regenerative one, a one that improves the benefit of the system through the time, or is a degenerative one? This is how used to look the conventional landscape. On the left of the image, we have maize crops under chemical and poison management. We can see that the corns had mineral deficiencies. So this crop had already the info to have pests and disease in the future. In the right side, we have a coffee plantation, very weak, a very unhealthy system. And this is the agriculture that I call rescue agriculture. We have a problem and we manage or we treat that problem. The vision which I want to shift is to a preventive agriculture. To prevent to have problems in the future as mineral imbalance, pests, or disease. So what we are going to learn is to shift from rescue agriculture to preventive agriculture. To understand how we reach these conventional or these practices as the current practices, we need to understand the 4,500 million years of coevolution of the planet Earth. This evolution was was evolved for the microbiology and the relation between the biotic and abiotic factors in the system. This is how the planet Earth developed through the millions of years of time. Here we can see a system that is imbalanced, a system or a forest that have many elements performing many functions. We can say that as much diversity in a system, more resilience will be that system. For understand agriculture, we need to understand the human's behavior through the history. The first farmers we can call the nomads, 9,000, between 9,000 years before Christ and 6,000 years. The nomads, they regularly move to and from the same area. They were hunters or gatherers, but they follow seasonally available wild plants. What I mean with this, they left time to time areas and the rest to be recovered and to come back the next season. So the system had time to improve again and be strong for the next, we can call visit. Afterward, the sedentary people was the citizens of the people who practice agriculture in a settled areas. What mean this? This means that they exploit or they use the same piece of area year after year without give a break. So this kind of system are degenerative. Afterward, the industrial revolution came with the fossil fuels and everything speed up. We got machinery, we got seeds, GMO seeds, we got pesticides, insecticides. So the negative impact on the system speed up. Some of the challenges that I've seen so far on my travels in Africa is deforestation, to cut the native trees, and then to grow monoculture. In this case, is a eucalyptus plantation in Central Africa. This type of ecosystems or landscape are not resilient because, like I said previously, doesn't have the proper biodiversity. When I talk biodiversity, I'm talking in general. Animals from micro to macro levels and also plants. We need to understand that as less diversity above ground, less diversity below ground. These kind of landscapes are not resilient in a long-term future. But this is not just happening in Africa, it's happening all over the world. This is an example close to my hometown in Spain. We can see olive in a very badly management. We can look the soil, bare soil, and we can see monoculture. So it's something that is happening worldwide. These kind of practices lead to erosion, and in this case, lose the soil, and that means lose the future capital. Forgive some numbers, I would like to share that if we lose 1 millimeter of soil surface per hectare is equal and 1 ton of soil losing by this kind of practices. This type of agriculture or landscape will lead to these big gillies, like for example here in Senegal. So in this kind of landscape, the agriculture is not viable for long. Also, this lead to the population of farmers leave the places and move into different countries or the city. Another bad practice that conventional agriculture does is that ignore biology in the system in favor to chemical intervention, fertilize, or poison. In this case, in the image, we can see the use of urea. And these practices just introduce the farmers in a loop, in a closed loop of input dependency, which they need to buy and to get from the shop all on over the time. So we need to understand this vision to go away and to manage our land with skill and knowledge. That I mentioned, this kind of the agriculture, rescue agriculture, is based in an input dependency of seeds, herbicides, machinery, fertilizers, pesticides, insecticides, fungicides. To have a viable crops, you need to get this kind of products and increase the need over the time and over the years. And at the same time, the quality of the food is increasing. I would like to mention this man, this technician wearing a mask. So that means that all these products and all these input are harmful for human health. But I like to share this image, like not everybody is able to use masks to be safe with this kind of products, of harmful products, poison, insecticides, etc. All these practices lead to a soil degradation worldwide. Here we have the map with all the depleted soil. And I would like that the people look South African region, and we can see how the state of the soil currently. We can see that it's very degraded soil, but in general, in all map, we can see the same kind of soil. So we need to reverse this and to create new systems through soil health. This is just to give an overall vision about other impact that this agriculture or the current practices, human practices, is leading. The freshwater resource is decreasing. The total forest biomass, the native forest, is decreasing, while the temperature change is increasing. We can see other impact, but I wanted just to point out the ones that these three true. This agriculture impact in the food quality that we eating. This food is not diverse, is not nutritious. We don't follow the principle food as medicine. As the food is not rich in minerals, we can see here through the 1900 to 2000 how some levels of some minerals is decreasing in the food, the quantity, the amount in the food, and we can see how increase some illness or some troubles that the current people is suffering, cancer, obesity, bone deformities, etc. This is due to the poor food quality that we can get. As we don't treat our plants properly with the current practices, we are going to have pest and disease incidents. The plant is going to be weak. This is due to deficiency and a mineral imbalance in the plants. So in here, we can see again the closed loop where we are into with this kind of agriculture. Every time the fertilizer recommendation going up, and at the same time, the pest and disease incident increased dramatically. So the pesticides application are needed more often while soil health degrades. Here we can see another example of a coffee plantation. We can see the soil, the depleted soil, absolutely, with the application of soluble salt on the surface. On the left side, we can see this one plant of that coffee plantation without any roots and absolutely weak plants. We need to reverse this situation. We need to be advanced to this situation. We need to avoid this situation. All this agriculture, of course, make impact in social and economic side. This is our agriculture that is subsidizing. Is whole for the health or for the allowance from the government or from the Minister of Agriculture. This create social barriers. The people or the farmers who had more, even they will increase the input. And the farmers who cannot afford this kind of input, they will decrease the quality of life. So increasing the distance between one people and other people. And then the organics business came. We need to understand that the organic certification is the same mentality, is an input dependency. Just what they do is replacement of the input to offer, but it's a market, it's a commodity. So our proposal for this series of webinars and modules is to shift the mentality and not just replacement of input. That is quite important approach and point to keep in mind. The organic business, what they do is, if you have money, you can afford the expensive food, the one that is certified. If you don't have resources, you have to get the cheap food. This may impact in the health of the people. So the health is becoming a commodity as well. I like to share this experience that I had in Mexico. When we visited 5 or 6 years ago, this is an organic avocado plantation. And what these farmers did, he cut 5 hectares of native forest to plant 5 hectares of organic avocados. That is not about what we're trying to share in organic or agroecology. It's to change how we think. It's not just a replacement of inputs. And then always, I like to protest, but also give a proposal. To me, doesn't make sense. It's just I protest, but I not give solutions. I like these sentences because to me it's quite important and show very well our approach. Is that you never change things by fighting the existing reality. To change something, we must build a new model that makes the existing model obsolete. We need to show that this kind of agriculture works. We cannot waste our time fighting the current practices. We need action. So organic agriculture or agroecology is a production system that sustains and improves the health of the soils, ecosystem, and people. We need to understand that the soils is the foundation for the agriculture or even for all culture, for citizens, for people. If we look after our soil, we will have healthy people which will be ready to have open mind and new ways to think and work. Our proposal to agriculture is to work with nature. We follow the natural cycles that happen in a natural ecosystem. On the left, we can see how a leaf is breaking down and all the processes. All that process of the breaking down of organic matter have involved many actions and many processes by itself. Fertility is not just about add fertilizer or input to the soil. is about to take advance at all the processes that are happening through this, for example, breaking down organic matter. The current agriculture, the conventional agriculture, deny these cycles. So we need to learn and to read the language of nature to be ready to understand what we are proposing in this course or webinar. We need to understand that the real engineering of the system are microbiology. On the left side, on the image, we can see a picture with a small creature all over, above the ground, on the plant, on the surface, and below ground. All that microbiology have a specific function. We need diversity of that microbiology. That microbiology is in charge to break down the organic matter, as we can see on top of the image on the leaves. Are the one that we can see below ground are the one that solubilize minerals. What means that? Make available minerals to the plants. So they weather in the rock bed and they give all those minerals to the plants. It's quite important to have diversity of microbiology, because if we got a diverse microbiology, they will be in charge to keep the system of balance and then inhibit the pest and disease, or even retain nutrients from lixiviation. We can think that to work with microbiology is quite difficult. No. Where we can get that microbiology, or where that microbiology is on the system, is on the surface of the soil in a natural ecosystem as a forest. On the right of the image, we can see leaves covered in white fungi. So in there, we can catch and reproduce that microbiology in a very easy way. Like here, I'm going to show in small steps. To mention that this webinar is not a technical webinar. This webinar, this session is just to give the overall idea about the vision, the challenge, and some of the practices that we are going to cover in deep in the following modules. We see on the left of the screen a healthy and diverse forest. It's in balance, no pest, no disease. So the point is to bring that information or that benefit from that healthy and complete forest to our agricultural lands, that we can see on the right. How we can do this? As I mentioned, we collect microbes on the surface, like in here. The white stuff, that is plenty of microbes, many millions of microbes. In a teaspoon of soil, there are 4 times more microbes than people all over the world. They are very tiny creatures. What we do is we collect this microbiology and we give food to them, at milk, sugar source, etc. we make a biofertilizer, and then we can spray that biofertilizer in agricultural or managed land. So we transferring the benefit from a healthy and diverse and resilient forest to our agricultural lands. These practices are done all over the world, since there's more small communities, as we've seen here in Zimbabwe, to big states in Europe, South America, or even in Africa. One of the goodness or benefit of fertilizer or liquid fertilizer is that in the composition are not just minerals. Also, they are other compounds, are vitamins, proteins, phytohormones, organic acid, etc., etc. So this agriculture is not just about minerals, it's about something else. One of the benefits by using these techniques or this approach is that we maximize the local source from property. We use some waste products or some outputs to create fertility. We need to understand that everything that is coming from Earth, we should bring back to Earth. So we work a lot that the people of the farmer understand the ingredients. If you give the knowledge and skills, not just recipes, the citizen or the farmer will be resilient in a long term. So one of my main focus when I teaching is to ensure that the farmers understand each of the ingredients and what is behind the recipe, the science behind the recipe. This works very well with all levels, skill and knowledge levels, from local farmers in a small village to university. This picture is in Nepal, in the Himalayan hills, and we can see that are working in there, work as well. So one of the benefits as well by using these techniques is that works in all culture, soils, or environments. Just we need to tweak small things. Another benefit by using these practices is that are not poison, are not harmful. We can see as in the image, kids manufacturing and managing this kind of fertilizer. We cannot see this kind of image with the solubilized fertilizer or the salt as the current agriculture works. Another benefit by using these techniques is a common sense technology. It's not rocket science or similar. It's just ferments. We can see in the image in one of the trips 2 years ago in Chimanimani in Zimbabwe, in the border with Mozambique. And we didn't have any problem at all. The people is quite happy by adopting these techniques. To me, the most important when we do agriculture is to build long-term fertility and community resilience. The image to the left is in Gutu last September. Another trip with SK partners When I say long-term fertility, this, what we are doing in here, or the people, the farmers are doing here, is a kind of compost or amendment. It's called bokashi. Is, we can say, a super compost and a quick compost. We can do this in 10 days. And then we use in the soil. We building long-term resilience plans that I mentioned previously at the beginning of the webinar. We need a healthy soil. If we have a healthy soil, we will have a long-term resilience on our system, our community, and also in our minds. We need to understand the principle of fertilization in organic agriculture. This one is nourish the plant for a short-term fertilization and fertilize the soil through amendment for a long-term resilience. This type of compost or amendments work very well and have fantastic results. And it's done with local material as well. This is an example of material used, for example, in UK. Ashes, clay soil, bran, cow dung, charcoal, wood chip. In the African context, we can change these ingredients for others with the same purpose. That I repeat again, the important is to understand the sources of the ingredient that we are using. And then we can find substitute in the local area or in the farm itself. Here we can see some of the results. On the left, we see a banana tree. On the right, another one. The same plant, same soil, same climate, everything the same. The only that we change is the left one we treat with bokashi and biofertilizer. The right one we treat with a conventional compost, organic practices, but a conventional compost. The one on the left is with enriched compost, bokashi, plus full spectrum nutrition with biofertilizer. I put this image because one image is much better than 1,000 words. Another experience in here with Rodi, an organization in Kenya, is behind pit. We can see corn under bokashi plus biofertilizer. In front of him, in the image, we can see corn with general organic practices at compost as well. So we go beyond organic. All this, the foundation is microbiology, organic matter, and mineral diversification. As I mentioned, a plant is not just elements. The mainstream agriculture is focused almost in only three elements: nitrogen, phosphorus, and potassium. For understand the importance of diversification of minerals, we need to understand the plant composition. The plant is composed by 80% water, roughly, the amounts, 18% carbon, hydrogen, oxygen, and nitrogen. Those 4 elements we can get for free in nature if we manage properly our system. And the left 2%, they are at least 42 elements so the plant can thrive properly. So you can imagine the nutritional imbalance that the plants can have if we just focus in those 3 elements, nitrogen, phosphorus, and potassium. But the plant is not just elements. For a healthy plant, we need to encourage hormones, organic acids, vitamins, proteins, amino acids, etc., etc. The gain of agriculture, of fertilization, is not just elements or minerals. It's something else, which current agriculture denies. How we can remineralize the plants and the soil? Through rock dust, ashes, bone meal, etc. We will see in the coming modules how we work in a very easy way, in a very farmer-friendly way with all these ingredients or source. Another way that we remineralize the plants and the soil is through seed coating. On the right of the slide, we can see seeds that are already coated. So when these seeds germinate, they are going to have already full spectrum elements and minerals at the beginning of the cycle life. What means this? That the seed, since the beginning, will have the proper info to avoid possible mineral imbalance, pests, and disease. This is a good example, as I mentioned, preventive agriculture. We prevent the problem. We work with the root of the problem, not with the symptom. This is another trials with maize. We can see on the left maize with compost. In the middle of the image, maize with vermicompost. On the right, corn treated with Bokashi plus biofertilizer. At the first look, we can see how the right maize is higher. But I would like to go into detail on the left maize block and the right maize block. The left maize block is with a normal compost with minimum minerals diversity on it. So we can see how the plants have mineral deficiency, and then as a result of the mineral deficiency, we have pests and disease attack here. On the right of the image, we can see how we treated a maize with full diversification of minerals. And it's not just about big plants or big production, big yields. It's about the quality of that plants. So it's a very good example of the different practices, even under organic management. This is the same trials, but in the other side of the world, in Nepal. Thin is 1,600 meters above sea level. And we did the same. Look the cup. And important to me to see when a maize is full mineralized is on the side, on the corner of the maize. We can see that even the middle one is not complete, is not full. This, for example, is a boron deficiency. Usually you are going to see the maize like this one. Through nutrition and fertilization, we can reach maize cobs full. Also look the grains, how big the difference. This is the same in Nepal as well, with the root system development. Good soil, healthy plant, healthy people. No pest, no disease. Food as medicine. What we see during the modules as well is the production of biopesticides and biofungicides to treat pests and disease. But we are going to treat in a different way. We are not going to kill the problem, the pest or the disease. What we are going to do is through nutrition, we are going to avoid that pest or disease happens. We have very nice, very good experiences combating the armyworm in Africa and just doing ash brew with local ingredients. And look, you don't need a good or big installation and nothing. The people in Africa already is doing this for 3 or 4 years, I think. The foundation of our agriculture is some type of recap, is do it yourself. Give the power to the farmers, knowing by doing. Maximize and understand properties, source. Reestablish the balance in managed land by mimicking natural system. Quite important, bring back the knowledge and decision making from companies to farmers. The companies take off all the decision making from farmers. We must bring back that power to farmers again. All this can be tweaked with local knowledge and sources. As Vanessa did in the presentation, from a small village to universities. This is quite important, some programs that we are following in Africa. What I'm doing is I'm creating a group of experts along Africa. So they try things, they make mistakes, they have an ongoing support by myself. But important to me is that they are able to share from experience to other people. So what we are building are local knowledge through experts. In Africa, Asia, South America, Europe, etc. This is another trials in Kenya, biology, with farmers. And we can see how some farmers use bokashi plus biofertilizer in small plots with farmers with corn as well, compost and control. We can see how bokashi plus biofertilizer, the yield is higher. So then they can see with their eyes that this works. It's not something that I say. So we have different levels for practice trials or run trials, and this is one of them. We can see on the right of the image how brightness and no pest, no disease at all in the maize. And also on the top image, how the maize is absolute, the cob is full. This is another research, is from a friend of mine a few years ago, rotting soils. And here we can see another trials with using biofertilizer, control plot, and DIP. The plant length is similar in all of them with all the treatment. But we can see as the yield is increasing with the biofertilizer application. Also, the sugar content in seeds, the quality in seed is higher with the biofertilizer application. And the seed infected after 3 weeks after harvest is quite low with the biofertilizer application, while with the DIP is a lot higher, 83% and 17% with biofertilizer application. And the cost in the right, we can see that is very, very low, the cost with bokashi, biofertilizer, rock dust, etc., etc. This is not one of my research, it's from Ethiopia, from a friend of mine. Here we have another experience, I think it's Rwanda. And you can see that the people doesn't need big installation and all that kind of thing. No, in the house, with local materials, local people, is possible. Just to mention that this is done all over the world. For example, we can see on the top left, Madame from Nepal doing biofertilizer. On the bottom left, bokashi production by hand in Colombia. Or on the left, biopesticides production in Europe. These techniques are recognized in a broad scale. Here is just some examples from a small biofactory in Uganda to a medium scale biofactory in Mexico or in UK. Of the bottom right image, a big biofactory in Costa Rica in a banana plantation. After 3 years traveling and working in Africa, I would like to share the challenge that I've seen so far at the one that we are going to work through the next coming modules. The first one that I see is that there is access to info about agroecology. The people cannot find in a very easy way what is agroecology, what is the vision, what is the theory, to have booklets, notes, videos. So we will solve these troubles as we're preparing lot of material that is going to be available for the students after each webinar. Another challenge that we've seen so far is the cultural assistance on community, the people beliefs. The people or the farmers at the beginning resist to change to a new techniques or a new vision. This can be for several purposes. One of the purpose or one of the reasons is they are afraid if they are doing good, they are doing bad, or who can support to me in this new path of this new vision of agriculture. Also, sometimes it's taboo to use a waste product to create fertility. So it's very important to work not just a replacement of input, it's a replacement of mentality or shift the mentality. Another issue or challenge that we're facing when we work in Africa is the access to ingredients. Can be raw materials, cow dung, or ashes, or can be the sulfates, or molasses, or milk. We already solving this problem along Africa. So we have substitute for all these ingredients and all this equipment. We will see all this on detail through the NDIF modules. Another challenge is the investment at the beginning to new equipment. Can be barrels, bucket, or drums, or even bulbs. We will solve all these trouble as well. This type of agriculture is possible with everything that we can find around us. The system thinking is as well a challenge in this type of agriculture. During the courses, I have many questions. This is just an example. And the people ask me, okay, I apply biofertilizers, an amendment, but then when is the proper time to use poison? We need to understand that biofertilizer and all these organic practices give life to the system. If we use poison, they are going to stop their action. So we need to rethink the way that we do and we use these practices. We encourage life. Poison deplete life. It's quite important to have ongoing support or follow-up. This is an example of Zambia. Mr. Michelos used to make one-day field visit per month. He's using last 2 or 3 years all this type of technology. So they create once a month a meeting in his farm, and he shares the production, the benefit, and all these techniques. It's important to have local people to sharing all these practices and vision of agriculture. Usually, what we do after training is a planning for real, because I understand that in the training, sometimes it's very condensed. When we finish the training, the people is overwhelmed with lot of good information. So it's important to help them to make a proper planification with everything that we're learning or we learn during the course, put the ideas, tidy up, etc. It's something that we usually do as well. Agroecology combines tradition, innovation, and science to benefit the shared environment and promote fair relationships and good quality of life for all involved from micro to macro level. If we make incidents in the micro level, we will change the macro level. Organic agriculture is make simple what is complicated. The industrial agriculture try to make everything very difficult. No, agriculture is very easy. It's just how you present this vision or this concept. Organic agriculture is about diversity. Diversity of thinking, diversity of mineral, diversity of plant, diversity of microbiology. I repeat again, as much diversity, more resilience. Organic agriculture or agroecology is about food sovereignty, about seeds, about the future. Is to bring back the decision into farmer hands. The farmers are losing the decision by the companies. The farmer has to be in charge of the destiny, or the destiny through knowledge and skill. We cannot rob the decision to the farmers. Organic agriculture is about look for future generation. Here we have students in an organic college. On the right, we can see the kids hanging around in the biofertilizer production. It's not harmful. Organic agriculture is to leave the soil better than how we found. Organic agriculture is about happiness, to be happy. We must be happy to make proper decisions. And organic agriculture is about to keep the culture of the citizens and the farmers. It's quite important not deny the culture of the people. The health of the soil, animal, and man is one and indivisible. If we look for the soil, we will for the man as well. Just to finish, for the people, I would like to mention the manual is you can purchase in my web, juanfranlopez.com. The table of content we can see on the left, and it's in a very easy way presented with the recipes. It's 42 pages. And the people can get through there, so they are going to have a bit of theory. Each recipe explained bit by bit, and it's a good way to share and to give other options to farmers. So from my side, I finished the presentation, the PPT, the vision and the concept that we are going to treat in the coming modules. So I think I leave the word for Vanessa. And now I think we are going to have a break, 10, 15 minutes, not sure. And then we will present in the modules, and we will have the chance for half an hour for question and answer. The question and answer are not going to be technical, are going to be focused in the presentation that just I did. So thank you all, and thank you, Vanessa. I give you the word. Thank you very much.
Thank you, Juanfran. That was really a great presentation. I think it's really explained why we are trying to transform the current industrial food system that we experience and that's being promoted globally, and what agroecology is all about, that we're trying to advocate for and share with people. And in particular, the fact that the soil is our foundation. That when we work with nature to build the soil, we have healthier production and therefore healthier people. And yeah, that's also that diversity is one of the building blocks of that. And often we speak about crop diversity and diversity in our production systems, but we really can't forget the diversity of microorganisms that are in the soil but that are also within our own bodies and on our bodies, and that help make us healthy. And without that diversity that starts in the soil and is in then our production systems, we are not healthy people ourselves. So thank you for that overview. As Juanfran said, we are going to take a comfort break now, just a short one of 5 minutes. So if we can be back at, let's say 11:20, and then Juanfran is going to present what will be happening in the deeper learning that he's going to be sharing with us over the coming weeks, how that's going to be structured. And we'll talk about what will be the next steps, and then we'll go into questions and answers. So just to remind everyone that if you do have questions, just please post them in the chat in the YouTube. And we'll feed that through to Juanfran to answer at the end. Thanks. See you at 20 past.
Thank you, Vanessa.
Hi, welcome back everyone to the second part of our webinar. I think we are just going to go straight over to Juanfran. As I said before, we'll answer everyone's questions in the question and answer session after this. So Juanfran, are you there?
Yes.
Great. Would you like to share your screen and carry on with the second part of the presentation, which is going more into what each module will be that will be coming up in the training? Thanks.
Okay, this is how we structure the next coming modules. There will be 5 modules I'm going to present right now. And each module is composed or is based with a theory webinar or a presentation with the recipes, the objectives of each recipe, how to make, why, substitutes, challenge that I found so far in Africa. And we will give, or we will allow 3 or 4 or 5 days for the people practice. And then we follow but a follow-up session where we'll see and we will work with the challenge that the people are having, question, doubts, etc., etc. I think start, or perhaps Vanessa is going to talk later deeply about the application and days and all that. The overall objectives of this online training is to build a strong knowledge and skill in the South African context about agroecology, do-it-yourself bio-input production, understand how to use, maximize and use and understand the source from the property by bringing the decision into farmers. We will shift from rescue agriculture to preventive agriculture. So at the end, each participant will be independent from industry in terms of knowledge, skill, management, technology, etc. How we call this agriculture is the being and knowing, doing and having. The first module is going to be focused in the system in nature and agriculture. So what we are going to cover in this module is to understand the system as a whole, indivisible. We cannot break apart the different systems. Imagine in the slide, in this picture, if we separate the water from the trees or from the microbes, then it doesn't work. So we will understand and we will recognize the system in our own system in a farm. And these systems are based in organic matter, microbes, and minerals. So in this first module, we will see the performance of the behavior, the relation between these 3 M's, organic matter, microbes, and minerals, the function, the general view of the function on all these factors, and in a very easy way, how to work with them. This webinar is not with follow-up. This is just to give the overall idea of system and understand the system, how it works in nature. So we will be able to mimic those systems in our agricultural lands. The second module is focused in organic matter and the role of organic matter in our system or in our farm. And we'll see how to produce the amendment or the supercompost that I mentioned before. It's called Bocassi. And also I'm going to give many farmer-friendly tools to assess visually your soil, the structure, the texture, the microbiology, etc., etc. So after this module, the theory webinar, we will allow 10 days so the people can practice, and we will come back 10 days later to see the challenge or to tweak or to share the experiences. So at the end of this module, the people hopefully will be confident by producing and using Bocassi. The module 3 is focused microbes and biofertilizer. So we will see the role of the microbe in agriculture in a very, very easy way. No panic. And we'll see how to reproduce native microbes, as I mentioned in the PPT previously, and how to transfer that diversity with all that diversity and function as well of the microbe to our managed land. We'll see the importance of the ferment in agriculture, and we will practice biofertilizer. In this case, we are going to make 2 or 3 biofertilizers. All these modules are going to be supported with short videos, presentation, booklets, manual. So at the end of each module, all the participants will have all the information in case they want to come back and refresh ideas, etc. For the module 4, I'm going to focus in minerals or elements and everything related with plant health. I didn't call this module pest or disease because, like I mentioned, a pest or disease incidence is due for a mineral imbalance in the plant. So what I'm going to focus is in plant nutrition and how if a plant is not balanced in a nutritional perspective, then we will have weak plants which attract to pests and disease. So we are going to shift the way that we look or we see pests and disease. Also, in the practical side, we will cover the production of biopesticides and biofungicides in a very easy way with local ingredients. We already doing this in Africa, so we will need to tweak the ingredients or the equipment to local conditions. And also will be supported for a series of videos and images, slides about a farmer-friendly way for plant assessment, nutritional imbalance, mineral deficiency, pest disease, and how we can treat all this from a preventive approach. Last module is going to be planning for real. So we will help to farmer and participant how they can put in practice everything that we already learned through the modules. And I will help to do a crop nutrition programs. We will set up farmer-friendly trials with everything that the people can apply or can practice, because to me it's very important, not just when we produce biofertilizer and all this technology, is to be supported with trials, with empiric proven. So when the people share all this in the villages, all this technology is supported with trials to show that this works. Also, we will work like the production, timing, and application on different local contexts, with the environment, with local source, etc. And then we will cover in general all the questions and answer that the people can have at the end of the 5 modules. So it's focusing very practical, in a very easy way to understand. And I think it's going to be a great course, to be honest. So it's preparing very well. And to me, the most important is at the end of the course, everybody is happy, everybody learned everything, and everybody understood everything that we are going to cover during the modules. So this is the overall view. And I think Vanessa now is going to go a bit more in detail in the form of application and all that subject to be part of this training. So Vanessa.
Thank you, Juanfran. Yes, so let me just put the video. So just to explain to everyone how we've conceptualized this and perhaps to answer some questions that have been coming up on the email. So the first thing is just to explain that, as I said before, originally Juanfran was going to come and train in South Africa for the South African organizations that are part of the Seed and Knowledge Initiative. And then with the COVID pandemic and not being able to have in-person training, we then discussed with him to run this as an online training. And with that came the opportunity of sharing it beyond the partners in Sky to more people in Southern Africa. So we've opened it up to South Africa, to Lesotho and Swaziland. We can't unfortunately make this a global training because Juanfran is a trainer who makes his living from doing this, and we are contracting him to help us with partners in Sky, and he's very generously agreed that we can open it up to the countries we've mentioned in Southern Africa. So unfortunately, if you are from somewhere else in the world and we're hoping to be part of this training, we can't accommodate you, and you can contact Juanfran directly to help, and to you can speak to him about doing training in your country. And not only because it's Juanfran's living, but also because the training is specifically geared towards our context and the conditions that we're working in, and the challenges that will come up for us. So that's the first thing. The second to tell you is that the actual course will start on the 25th of August. It's going to start with the systems module, which doesn't have a practical component. So that will be the first theory training with no practical component. And then after that, it will go into a system of a theory lecture, and then time for people to practice the recipes that are taught during that theory lecture, and then followed by a community of practice where people who are actually implementing the recipes and working on the ground, either on their own farm or facilitating a group of farmers, can come together and discuss the challenges that they've experienced and what they've observed. So the first one of that, which involves bokashi, has a longer period between the theory and the community of practice of 10 days to allow for that to develop, because it has a time period. And then after that, we'll go into a cycle of theory on Fridays, and then the community of practice on Tuesdays. And that will all end on the 29th of September. So it's going to be every week. It's quite an intense program of learning the theory and then going into practice. Now, to be part of that training, we're going to be sending out an application form. So everyone who's signed up to be part of this introduction will receive the application form. And we're going to be asking you some questions around where you are practicing. If you are part of a group, we can't, it's because there's a mentoring component of this where Juanfran will be giving you mentoring as you go, we can't deal with everyone together. So if there are groups of farmers, for example, we're going to ask you to please choose a lead farmer or your facilitator, and some lead farmers to be part of the community of practice, and then work with the rest of the group. Although you will all be able to watch the theory lecture, but for the community of practice. But we'll work that out also as we go and we receive the applications. So the application, as I said, it's going to be sent out probably tomorrow, and then we'll need you to return those by the 10th of August, and we'll let everyone know promptly after that who can participate, and then we will call a meeting of all the facilitators to make sure that you are ready for the practical, that you know what ingredients you need to find, what extra equipment you might need, that you need to source, and if you are having problems, we can help you to find alternatives, as Juanfran mentioned. So that's, in a summary, what's going to happen. And we'll put all that information also in the intro to the application form, so you can be quite clear what's going to happen in each session, what the topic is again, as we've said. So we've got some questions that have come up. There's not been many. The first one, has been around the access to the presentations. So for today's presentation, after it's been screened live on YouTube, it will remain on YouTube as a publicly accessible presentation that you can go back to. I know some people have had problems with connectivity. Some people have been in towns that have lost electricity and got cut off. So that YouTube will be there. You can refer back to it if you missed anything or want to go back. And for those of you who are working with farmer groups, it will be there to show again at your leisure and to work with the groups that you're with. So that will remain. In terms of the deeper online course, unfortunately, it can't be a public online resource in terms of the presentations. But we will definitely, for all the people who are participating, make sure that you have access to the PowerPoints, the booklets, the videos, the things that are extra resources that Juanfran mentioned. So you, if there's any problems with connectivity and all those kinds of issues, we'll work through them together and make sure that you have all the resources that you need. So don't worry about that. And then I'm going to hand over now to Juanfran to answer the more technical questions that have come up. Yeah, and to share more. Thanks.
Thank you very much, Vanessa. So yes, I'm ready for any question that is coming through.
So I think the first one is, how important is it to test your soil for nutrients?
It's quite important in terms of we know what is lack. The periodic table on the Mendeleev table with the elements have 92 different elements. The current agriculture just emphasize 10 or 12. It's important to know the mineral state of your soil, because then you know the foundation and the imbalance that we created. I wouldn't be too worried about soil element testing again and again and again in a regular basis. What usually I do is I make one maybe soil minerals test every 2 or 3 years. But it's important to know the base and the current stage of or mineral imbalance in our soil. Usually, what's happened as well is that the people does a soil test, and the people always focus in the deficiency of the minerals that they see. Usually, the deficiency of those minerals, we need to treat not the deficiency of the minerals, the excess that create deficiency in the minerals. So it's an important tool, but it's not a tool that we need to be much worried about in a regular basis. But it's important to know the base of our soil and our crops. So yes, now there are other methods, the other methodology that they test the sap analysis. The sap is like the blood of the plants that give more accurate vision of what really your plant is, what really your plant is getting the minerals, because perhaps you have the soil pool, the soil minerals, but the plant cannot take those minerals. That can be for several reasons. For example, for no diverse microbiology, or no a healthy relation between the soil and the plant. So instead that is like we have that food, those minerals in the soil, but we are not able to use them. So it's an important tool, the soil mineral test, but doesn't give you the true state of your nutrition in your system. Another question is coming. What are your opinion? Beneficial cover crop?
So the question is, what are your opinions on beneficial cover crops in order to regenerate depleted soils? Growing mulch, fixing nitrogen, and building soil organic matter.
Absolutely is a key practices. For several reasons. First, we are adding organic matter into the soil. We adding diversity, as much diversity of cover crops as fish or legumes or gramíneas, etc. We are going to have more diversity of processes in the decomposition, also more diversity in microbiology. Is the principle that I shared at the beginning, at much diversity above ground, much diversity below ground. We need to have clear, and we, as I said and mentioned, we need to mimic a forest. As more close we work as a forest, less expensive is the agriculture, more fertile, more diverse. So a soil of a forest is covered all year around. So we need to mimic those systems. So it's absolutely a key practices, green cover or with different type of plant like legumes, melliferas, where the bees can pollinate, biomass with gramíneas, fixing nitrogen with legumes. Yes, is key done, and the trouble that some people, or the mistake that some people does along the time is they plant or they grow cover crops, but afterward what they do is they till for introduce that organic matter on the system. So the benefit that you talk to perhaps half a year to cover crops, you are losing all that structure that you improvement, all that microbiology, all those benefits that you're creating. When you till, you destroy again, and it's like a start since the beginning. So yes, cover crop is a key practices. We will see something about cover crops in the second module of organic matter. So yes, I'm already preparing that presentation, and yeah, so we will cover that as well. But I'm going to write to be a bit more in detail. So thank you for the question.
Okay, thanks. One other question that came through that perhaps you can explain a little bit was around where to do a course on the soil food web. It was referring to a particular person's soil food web. But maybe just explain what the soil food web is and how that applies.
The soil food web was a concept that biologists and scientists in England developed 20, 25, 30 years ago. The soil food web means the relation between the different trophic levels, starting with the sun, plant, and then all the microbiology involved until reach the human. That means the plant, the root of the plant have a relation with the more tiny creature that is bacteria and fungi. Bacteria and fungi are the ones that feed the plant. So we need to understand that the communication and the fertilization of the plant is not through amendments or it's through chemical properties as well, but mainly in living system is through bacteria and fungi. So the bacteria and fungi is the first trophic level that is in charge or is in relation with the root plant, the one who feed the plant. About this level of bacteria, fungi is the protozoa and nematodes. Protozoa and nematodes are a bit higher organisms, and they are in charge to keep in balance the bacteria and fungi population. If we continue with the trophic level, the next trophic level will be the microarthropods, the very small insect that you can see, for example, in grass when you are walking, something like that. Many small creatures or insect jump, very, very small. That is the next trophic level. Next trophic level will be the macroarthropods, the insect. Next trophic level will be the birds, who are in charge to control the microarthropods. All then the above levels are in charge to control the below levels. Next one will be the mammals, for example, a deer or any kind of mammal. They are in control to control that mammals, that small birds or other animals. And on top of the trophic level are the human beings. So in here we can see how the diversity of the trophic level in the first level, for example, bacteria and fungi, are in relation and connection, direct connection with humans. Always I say humans are, each human are in charge of many millions of organisms. So the soil food web is just that connection and how to improve, develop, and work with this different type of microbiology. We need to understand the first is the sunlight, plant, bacteria, fungi, nematodes, and protozoa, micro, arthropod, macro, mammals, humans. So that is the link of the trophic level. Yeah. So if someone want to know more in detail about this, they can contact with me privately by the mail through my web. The mail is info@juanfranlopez.com.
Okay, thank you. Someone asked a follow-up question around you mentioning the testing of sap in the plants, and they wanted to know how to do that.
Yes, that can be in two different ways. You can purchase some technology that is similar to the pH meter or that kind of thing. And then what you do is, this technology is very expensive for farmers. What you do is you have different machines, one to test, for example, calcium, another one to test ammonium, nitrate, potassium, phosphorus, and then you know the the quantity or the amount of, for example, calcium that is, we can call for make a similarity in the blood of the plant. That is one way how you can analyze the sap, but what they recommend is to send to a lab. There are many labs in South America, North America, Europe, Asia, and I guess in Africa as well, where you can send 20 leaves, 30 leaves, and in 2 or 3 days, they say to you exactly the amount of each element that is, or the plant is using in that time. It's a very powerful tool because you know in the real time the state, the nutritional state of your plant. The soil that I mentioned before, you know the amount of minerals in the soil, but you don't know if the plant is taking of those minerals. There is another type of analysis, is the tissue test, but those analyses are not 100% reliable in the state of the plant, or the current state of the plant. Why? Because those minerals are the ones that already worked and already create tissues or the stem, the stalk, etc. But you don't know if the plant is using them. So with SAP analysis, you have in real time, one day to another day, all the nutritional imbalance. Through biofertilizer, you can create again the balance in the plant. Because one of the things that we saw with the application of biofertilizer is that usually the mineral deficiency we solve in 24 hours. We have many experiences with a plant with deficiency potassium, nitrogen, and with the foliar application of biofertilizer, the deficiency disappeared 24 hours. Usually 24 hours is the photoperiod of the plant to assimilate minerals. We can call as a general rule. Not with all the minerals is the same. We need to subdivide mobile elements with non-mobile elements. Each mineral, the behavior is different. But the SAP analysis so far, with all my year of experience, is the real tool that say to you the current state of your plant. So you have 2 ways, or you can purchase the material, which is very expensive, or you can send to a lab in a regular basis. This is not like a soil analysis test or soil sample test that I mentioned to do once every year, 2 or 3 years. With SAP analysis, usually I say maybe twice a year, depending on the growth stage of the plant. And then you have the decision in 24 hours to give the deficiency to the plant. And in 2 days, the deficiency is sold. So to me, it's the best way to work with the nutritional balance of the plant. Thank you.
Thank you. 2 more questions. So the first is, if you don't have a forest adjacent to your community, where do you collect the wild microorganisms?
Yeah. The importance of these microbes is that have to be native microbes. What I mean native microbes? Because those microbes, if are for that area, from that local area, those microbes have the memory of all the biological processes that have been happening in that specific area for years of evolution. We can call 100 years, 200 years. So they got the memory on all the processes with all the benefit that microbiology is working in that place. I mean, to me, it doesn't make sense to bring microbes from Spain with this type of soil, this type of climate, weather, etc., for instance, to South Africa, because those microbes doesn't have that ability with the local context. So how we work if you don't have a native forest? We will see deep in the module course. So this is a bit of technical question. We'll create our own forest in our farm. by using the different biomass or material that we collect from, for example, the crops. So at the end, we will have a small forest, maybe 1 or 2 square meters, where we can get that microbiology. So if you don't have a forest close to you, you can create that condition. So we will see all that in deep in the modules, in the second module, no, in the third one. So yeah, thank you.
Another question. We have a lot of biochar. Will the bokashi charge the biochar in the 12 days?
Sorry, the biochar?
The person asked, I have a lot of biochar. Will the bokashi charge the biochar in the 12 days?
Yes. The biochar is a key ingredient. The trouble with the biochar is how you use the biochar. Biochar is an ingredient that is full of pores or small gaps. Those small gaps need to be filled up with minerals and microbes. Usually the people use biochar straight out in the land. The experience that we have is that during the first year, the yield decreased. Why? This is done because the biochar need a 1 year period of time to allow to the microbiology around that piece of land or that biochar go and occupy those pores. So if we apply biochar straight away, we need to allow to fill up those pores. For example, biochar is very good for a long-term source of humus because biochar, the composition of biochar is very slow. So it's like a long-term source of humus in your land. When we apply this biochar, or when we use this biochar in the bokashi production, with those 10 days, we allow to fill up all those gaps in the biochar. The bokashi that we are going to do is going to be complete with all the ingredients. But that doesn't mean that if you don't have biochar, you cannot make bokashi. No, just the quality of your bokashi production will decrease, but we can still do bokashi. So I recommend to read about biochar. If you search in the net terra preta in the Amazonia. So in there, you are going to have an overall idea about the benefit and the goodness by using biochar. So yeah, I have some experience. I remember I think it was in Zambia that the people planned to cut a native forest to make biochar to make bokashi. So that's not how we approach this. So we were in time to stop that management, and we say, no, it's much better if we don't use biochar, instead that cut a native forest to make biochar. So we need to have clear all those concepts. Thank you.
Okay, there's a follow-on question about whether one can collect microbes from the sea.
From the sea?
Yes.
Yes, but the microbiology in the sea is quite different. So from the sea, what we get in the benefit are the minerals. The minerals in the sea is very rich, the amount, because within all the erosion, all the sedimentary rocks in the river, etc., weathering all the elements in the different rock or stones in all the way until the sea. So in the sea, we got around 72 different minerals. I recommend to search in the net about sea crops, and then you can see how we can get the benefit from the sea. But microbiology is not the microbiology that we are looking for transfer into our system. Why? Because a sea doesn't have all the relation and all the elements that we try to mimic, like a forest. So what we work with the sea is getting minerals and using those minerals. The result that the parents that we have in using Ormus is how the recipe is called, is amazing. Is absolutely no pest, no disease, big plants, brightness, healthy. So I wouldn't collect microbes in the sea because are absolutely different system that we are working with.
Thanks. All right, we've got one question about soil labs. So let me try answer that to Donna. We've heard about a lab in Stellenbosch area that tests microorganisms and does different kinds of soil testing. So we can send those details to you. I've just got to find them. I don't know, Juanfran, if you've heard about any other labs. The question was around most of the labs here are just focused on the nutrients for specific crops. They don't do that comprehensive testing. So that's something we need to research more in South Africa, who's looking at it in a more holistic way.
Yeah, the important is to follow with the same lab over a period of time, because different lab analyze the soil in a different way with different reagents. So if you change from one lab to another lab, all the readings are going to be totally different. So it's very important to find a proper lab where you feel comfortable with what that lab offer to you, and then follow over the years, because then you will have the same base with the same type of analysis. I don't know about any soil lab in South Africa, but I can search in the net and ask for what we are looking for. We can share that through the modules. But I'm for sure that there will be a very good lab in South Africa.
Okay, and then there's a last question that came on WhatsApp because the person lost connectivity completely in their town. She said that she's a soil scientist or an ecological soil scientist, and she just had a concern, and she said that from the part that she saw, she was concerned that we are promoting biofertilizers using anaerobic microbes, and can one put anaerobic microbes on an aerobic system, and she was concerned that that wouldn't work. So perhaps you could just explain that part.
Yes, that is the big misunderstanding about biofertilizer and about how should divide microbes. This question always with the people that is not familiar with biofertilizer, it always is coming this question. We need to keep in mind that the microbes are not just aerobic or anaerobic. Okay, they are in between a group that is facultative microbes. The aerobic microbes perform with oxygen. The anaerobic microbes perform without oxygen. The facultative microbes perform in both environments, aerobic and anaerobic. Depends what is the environment around, so they will perform as aerobic or as anaerobic. The second point to this is that there is a big misunderstanding as well, because was promoted last 20 years with the aeretic composting and that technology, that only we have to encourage aerobic microbes in the soil. No, in the soil there are aerobic microbes, there are anaerobic microbes, and there are facultative microbes. So what we are doing with the biofertilizer, and this is key, we are using the metabolisms and the processes of the facultative microbiology, that is the one that we getting from the forest, to digest all the elements that we are going to put with the ingredients in the biofertilizer. So it's not the short approach or the short understanding that is aerobic good and aerobic bad. No, we need, like I mentioned in the PPT, we need to shift to a diversity. And diversity means all microbes. And with the biofertilizer, what we do is a ferment process. In a ferment process, what happens is you break complex molecules into simple ones. And those simple ones are more available to digest for plants. So in the biofertilizer, what we do is to use that facultative, is not anaerobic, facultative microbiology to digest and chelate. Chelate is the viability of the minerals, is chelate those minerals, proteins, organic acid, etc., etc., etc. And then the ferment process finishes. What you apply is, we can say, a mix of proteins, organic acids, elements, chelated elements, or vitamins, hormones, etc., etc. And in the biofertilizer, the less important is the microbiology that we are going to apply. It's a different technology than an aerobic teas. That the most important is the microbiology, but you don't put much minerals. With the biofertilizer, what we focus is in the byproduct of the metabolisms of the microbiology. After the fermentation process, after 30 days or a month and a half, what we are going to have, now with all the microbes, they are going to sporulate. When they finish all the metabolism, they are going to sporulate. So what you spray at the end is a pool of all those elements, etc., 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 and a spore of microbes. Those spores of microbes, once they reach the environment, some of them will wake up and another will still in a spore or in a dormant situation until they find the proper environment to wake up, we can say. But it's a different approach. The biofertilizer are not focused in microbes, are focused in the byproduct of the metabolisms of the microbes. That is done through the fermentation process. So, and another thing, and I would like to repeat again, we need to understand that aerobic is good, anaerobic is bad. No, it's diversity. In the soil, we have anaerobic pockets, and in there we have microbiology. The trouble with this agriculture is the diversity, and we cannot deny any type of microbes on the system. The trouble is, for example, when you have in your soil just anaerobic microbes. Yes, then we will have a problem. But the same problem we will have is just we have aerobic microbes. So we need to understand that misunderstanding, and this is due to last 20 or 25 years that aerobic is good, anaerobic is bad. No, diversity is good, no diversity is bad. The aerobic teas are different to biofertilizer. So aerobic teas are focused in reproduce microbiology and spray or apply in your land. Biofertilizer is focused in compounds as the product of the microbes metabolism through the fermentation process. So it's a different approach or a different technology. Hope it's clear. But yes, this question is coming yes, every time that we present, but it's normal.
Thank you. Thank you very much, Juanfran. I know that was a bit of a technical question to end off, but since we had a bit of time, I thought we could pose it since it came in. Thank you, everyone who's been with us this morning. I haven't seen any new questions come in, so I think we'll leave it there. But if you do have questions, you can always email us, or as Juanfran said, if you've got technical ones, you can contact him through his website. And we will then be in contact with everyone with the details of what's next and how to apply for the course if you are interested. Thank you. Thank you very much for your time.
Thank you, Vanessa.
Goodbye, everyone.